Okay, now we have some more samples that we're doing on this, and here we're actually setting up ratios into proportions or equations. Remember, proportions are equations, and we're solving for an unknown. We have 1 over 2 equals 28 over x. I want to find x. Well, what do? Cross multiply, get our cross products. Product of the extremes, multiply the extremes, times it equals the means. 1 times x equals 2 times 28. X equals 56. Fairly simple. Again, take our cross products. How do we do that? 4 times the quantity 2x plus 3 equals 8 times 5. 8x plus 12. Please be sure to distribute that all the way across. Equals 40. 8x equals 28. We subtract the 12. Divide the 28 by 8, and we come up with x equals 3.5. Now, put this back in there and make sure that equals. Because if it doesn't, we're in trouble. You start over. So put this 3.5 back in there and make sure I did it right. Again, we do this. Cross multiply. 4 times x plus 1 equals 3 times x minus 1. We distribute. 4x plus 4 equals 3x minus 3. Subtract the 3x. X plus 4 equals negative 3. X equals negative 7. Put it in there and make sure the ratios are equal. Have 6x is to 27 is 4 is to 3. Cross multiply. 6x times 3 equals 4 times 27. 18x equals 108. X equals 6. Plug it in, make sure it works. 3x minus 5 is to 4 as negative 5 is to 7. Alright? Cross multiply. 7 times the quantity 3x minus 5 equals negative 5 times 4. 21x minus 35 equals negative 20. 21x equals 15. X equals 0.07143. Check those out and make sure they're good. Got a couple more, and we'll be done with this proportion thing here. Here's some more proportional problems that we like to show you. They're a little challenging unless you know how to approach them. You know how to approach them. There's no big deal in the way it goes. And basically, it's looking at the ratio of the sides of a polygon to the perimeter of another one. And what we're looking at here is it's telling us that the ratio of the sides of a triangle is 7 to 9 to 12. Now this is just simply another way of expressing a ratio and putting it so that we can compare multiple things. In other words, basically we've got 3 sides, and to each other, one of them is 7, one of them is as if it were 9, one of them is as if it were 12, and we have a triangle that has a total perimeter of 84. Now, it looks like we just have one triangle. They want us to find the sides. Now, the secret to this is we don't have one triangle, we have 2. What? There's only one? No, coach, it only shows one. It has a perimeter of 84. And the sides are 7, 9, and 12. Well, add 7, 9, and 12 together. What do you get? You certainly don't get 84, do you? So we're going to pretend we have 2 triangles so we can make this right. Triangle number 1 has sides of what? 7, 9, and 12 for a total perimeter of what? 28. Got it? So we're going to pretend that there is one triangle that looks like that. Now there's another triangle that has a total of 28, and we're going to set up proportions so we can solve for the sides. We have 3 sides, x, y, and z. We're going to find them. So our first proportion is 7 is to 28, as x is to 84. The perimeter of our first imaginary triangle is 28. The perimeter of our real one is 84. So 7, the side 7, is to 28, as x is to 84. We set that up, get our cross products, extremes equals the means. 7 times 84 equals 28x, and when we do that math, we come up with x equals 21. Same thing, the second one is 9 is to 28 as y is to 84. Do the same thing, y equals 27. Next one, 12 is to 28 as z is to 84. We do that one, we come up with 36. Now, to check it out, add x, y, and z, and we should get what? better get 84. 21 plus 27 plus 36 equals 84. Therefore, you're good. Look at this, study it, look at it, study it, look at it, study it, understand. We have one triangle that looks like this, okay? Its total perimeter is 28. We have another triangle that has a perimeter of 84. We want the sides to be in the same ratio as that is. That's how we set it up. Now, the next one is a little even wilder because it goes against all the conventions and rules and definitions and equations that we have for angles of a triangle. But we're going to show you how it works. We have to play a little trick. Play that trick and it'll work out. Okay? This one is the ratio of the measures of the angles of a triangle are 4, 5, and 6. In other words, we've got 3 angles in a triangle, and they're set together where 1, if I set them up, they're 4 to 5 to 6 over the total. Well, again, we don't have one triangle we're trying to find. We got 2. And this one really is imaginary, because we're going to add the angles of our first triangle, and we're going to say, wow, we're going to add the angles of 4, 5, and 6 and get 15 and say, wow, our first triangle has a total angles of 15. Now, you not both know that's not true. You not both know that all triangles, regardless of what they look like, have total angles of 180. But we are going to pretend there's an imaginary triangle out there that has an angle of 4, an angle of 5, and an angle of 6, or a total of that of 15, so that we can solve this problem. Okay? Play along, pretend with me, and you'll understand how it works. Now, what's the total of the real triangle we're trying to find? They don't give it to us, Coach. Well, of course they don't give it to us because we're supposed to know it. What's the total of the angles of a real triangle? 180. That's why this one's imaginary. Really imaginary, because we're totaling it up to come up with a total angle of 15. Here's how this works. First angle is 4. Ratio of 4 is to 15. Part to total is x is to 180. Okay? This is our real one. Do our cross products. X equals 48. Second angle. Ratio of 5 is to the total of 15. Our second angle, y, we don't know, is to 180. Do our cross products. Y equals 60. Third one and last one. 6 is to the total of 15, and z is to our total of 180. Do our cross product. Do our cross product. 6 times 180 equals 15z. Z equals 72. Okay, add all those up. We better come up with 180. 48 plus 60 is 108, plus 72 is 180. Okay, study those. You'll have them on test. And you need to know these little tricks. You know, add these up. There's one triangle with a perimeter of that. Here's our second one. Here's another triangle with a total of angles of 15. Oh yeah, right, that can't be true. We know it's not true. We're playing games. Okay? But play the game so you can get the answer. Okay, and that's how you play that game. Okay, we're done with this section of proportions.